Welcome to this video for Python versus R for data analytics. In this video, we'll be discussing reinforcement learning, which is a technique used to evaluate data using the upper confidence bound algorithm. And with this technique, this is applicable to Google, as Google can use it to evaluate an ad campaign that they're doing, where they have 5 different ads that they are testing out with users and want to figure out which ad is best to maximize returns and engage their customers with. So what the upper confidence bound algorithm does for reinforcement learning is tracks the click-through rates for ads in the campaign over time, and each time a person logs onto a social network, Google will choose to display one of these ads in their campaign. And if a user clicks on the ad will receive a reward of 1, and when a user doesn't click on an ad, it receives a reward of 0. But what the algorithm does over time is to keep track of each ad's rewards. So Google can then know which ads are being clicked on most often by looking at the results, and then they're able to choose which ad to display to the next user by evaluating the results of the algorithm. So here we can see one of the major real-world applications is for targeted ad selection. And essentially, the rationale is that the algorithm uses data observed up to a certain point of time to determine which action to take immediately following the most recent occurrence. So based on whether an ad was clicked on by a previous user, Google can then determine if they want to show that ad to the next user as well, or to show them a different ad because they think that one would be more successful. So how does this work in Python and R? It's relatively the same in both languages, but first we'll run through Python. First we'll import the libraries and get the data set, which is just 5 columns, one for each ad in the campaign, and then 4,000 rows representing the 4,000 different rounds that users will go through and that the algorithm will learn from to see which ads are getting the most clicks and are being shown to users most often. And that's done using the upper confidence bound algorithm that we'll run next. And here with the formula for the algorithm, after that is executed, we'll be able to see which ads are selected, how many times those are selected to be shown to users, if the ads are being clicked on or rewarded, and the sums of rewards for each ad. So whichever ad in the end has the most rewards will be the one that Google knows is most successful for their campaign. So we implemented the algorithm, and then we'll see the results in a histogram to see which ad is most successful and will maximize Google's returns. And here we can see it is the ad at index 4. And now we'll run the same technique in R. And here it is very much the same, minus importing the libraries because there are no libraries here for R. Then we'll implement the algorithm again, which is the same as in Python, just slightly different syntax. And then we'll see the histogram. And here we can see that it's just slightly easier to read. We know that the 4th ad in the campaign is the one that's being shown to users most often and is the one that will be most successful for Google. So when it comes down to it, this technique is extremely similar in both Python and R. Because this technique doesn't have a specific library to use in either Python and R and just requires coding the algorithm from scratch, there's really not much difference between the two languages, which brings us to the scorecard. The main difference here is that R is better in terms of the code volume and ease of use. It has fewer lines of code, but then the aesthetic and clarity is virtually the same for both languages. In terms of popularity, Python is slightly more popular. They both have a ton of community support though, and are both used often for this technique. For execution, performance, and output, the execution time is almost identical for Python and R, but the output in terms of the graphical output in the histogram, we found that this histogram in R was slightly easier to interpret, but overall the console output and the execution time is almost the same. Finally, in terms of scalability and transferability and training and testing, The two languages are highly comparable and receive virtually the same exact score. It's easy to transfer new data sets in both languages, and they have similar abilities to scale. And in terms of learning to utilize these languages for new hires at Google, both languages are extremely valuable to learn and have the same time for a learning curve. So all in all, the total score for Python is 3.7, and for R it comes out to 4.0. And our recommendation ends up being that R might be slightly better than Python for this technique, but ultimately it might come down to the fact that a person would choose to use Python over R or vice versa, depending on their previous experience with the languages. So basically, Python and R, either one would suffice for this technique and would provide adequate results, but it may just come down to the user's previous experience. And in this case, we determined that R would be slightly better for our use case, but again, it may be subjective to the user. Thank you for watching this tutorial, and you can see more videos on our YouTube channel.